Hi, everyone. Welcome. Thanks for joining this introduction to profiling. Yeah, I will give the word to Lilian, who will present this presentation. And I will monitor, together with Rich, all the questions that you can pop into the Q&A tab of Wahoo. And at the end, we will have a Q&A session. So thanks, Lilian, if you can take it over.
Thank you, Ardan. So welcome everyone to this introduction session on profiling. My name is Lilian. I'm from FHIR. So I have been involved at FHIR since 2017, so for 5 years now. And I've been working as a FHIR consultant, mainly focusing on the modeling work. And currently I'm working on the Dutch bird care standard and also a project for automated delivery through FHIR to the Dutch National Intensive Care evaluation, for which I will have a session as well later this week. So before we start, first some words about our company and what our company has to offer. So in this session, yeah, we will be focusing on profiling. So we have some tools that can support you in doing your profiling work. So we have Forge, a profile editor, and of course, Simplifier, a collaboration platform that you can use to collaborate with others and publish your work. And implementers can use that to explore your work. And also, we have recently added the FHIR terminal, which allows you to automate the publishing and validation process and add some quality control to your projects. And we also have, of course, our FHIR server and the FHIR.net API. And if you would like to know more, please visit us at the FHIR booth downstairs, or for the virtual attendees, you can also reach out to us through mail or through Wahoo. So the topics that I will be covering in this presentation are first the need for profiling. Then I will tell you a little bit more about the FHIR conformance layer and the conformance resources that are involved in there. Next, I will dive in a bit into profiles and extensions, then talk a little bit more about packages and end with some slides about registry and tooling. And hopefully after that, we will have some time left for the Q&A of this session. So for the virtual attendees, you can just post it in the Wahoo app. And for the in-person attendees, Ardan will be walking around with a microphone. So the need for profiling. Why do you need profiling? Well, FHIR provides a platform specification. It offers a set of standard building blocks that need to be generic enough to cover all kinds of different use cases around the world. It's an international specification. And yeah, we need to adapt that to specific use cases that we want to support. So the process of adapting that very generic and open specification to your specific project or use case is what we call profiling. So when we are profiling, yeah, we specify which resources and which elements do we need for our implementation, which do we want to use and how do we want to use them. But also, if you offer a RESTful API, you can adapt that as well to your particular implementation and restrict which API features that you would like to use, or even extend them with custom interactions. And also, you need to describe the terminology that is supported in your implementation. And yeah, you need to address the question how to map all of these to local requirements. And you would like to describe this in a structured manner, because in that way you can publish it in a repository and implementers can use that structures, for example, to drive validation use it for code generation, or even build a user interface upon that. So just a little bit more about the FHIR conformance layer. Yeah, so this is a list of some conformance resources that are in there. It's not complete, and I won't address all of them, but I will go through the main conformance resources that you will encounter when you start profiling. So the first one is the structure definition. You use the structure definition to define your data structure. So every core resource, core data type that's already in the specification is defined by structure definition. And also when you are building profiles or constraints upon that core resources, you are actually creating structure definitions. Also, extensions and logical models are defined by structure definitions. Then we have the operation definition. So if you have this RESTful interface, you can define interactions and operations that you would like to support. And you do that by giving it a name, specify the input and output parameters that it needs, and a textual description of the behavior that it should have. And in this way, and also, of course, on which resources that operation works. And in this way, implementers know how they should build that operation, but also a client knows how they can use that operation, how they can call it, and what input they need to send and which output they can expect from the server. And you can extend the API, or you can restrict it by saying, I don't need all the operations that are supported by the FHIR specification, but just this limited set of operations. Also, you can define search parameters. There's a couple of standard search parameters in the core specification. And when you go through the documentation and you scroll all the way down in the documentation of a resource, you can see which search parameters are supported by that resource. It's not the case that there's a search parameter available for every element in the structure definition. So sometimes you might need to define your own custom search parameter if you would like to support a search parameter for that element where there's not yet a search parameter for available. But also, when you add extensions to your profiles, then of course the extensions are not known yet by the system. So you need to define a custom search parameter for that extension if you want to be able to search upon that extension. Then we have the capability statement. If you have a RESTful API, you need to, a FHIR server always needs to provide a capability statement whenever it is requested upon. And that capability statement describes all those conformance resources, all the operations that it supports, the resources, the profiles, interactions, search parameters. So that's one way to use the capability statement. But of course, you could also use it to define which capabilities should be supported by a system and add it to your implementation guide. Next one is the structure map. You can use the structure map to translate or transform one structure into another structure. And you can do that by using the FHIR mapping language. And later on this week, I believe it's Thursday, but at the end of this presentation, I will have a slide as well with a couple of modeling sessions that are interesting for you. So I believe it's Thursday that there's a session on FHIR mapping. So if that interests you, then please attend that one. Then the implementation guide. When you have created your set of conformance resources, then of course you need to document them and create an implementation guide You can either do that in a PDF or have some nice website so that implementers can go to that implementation guide and see how they need to implement those conformance resources and have this set of related conformance resources available in one place, one implementation guide. So when I use this term, I now mean the documentation, but there's also a structured equivalent of that in the FHIR specification, which is the implementation guide resource. And you can use that resource. Within that resource, you can point to all those conformance resources, but also to some editorial content that you may have. And you can use that implementation guide to resource to publish your implementation guide and automatically generate that website. And you can also use it to automate validation of conformance to your implementation guide. So yeah, here's a visualization of that. So we have this implementation guide resource pointing to all those different conformance resources that you created, but also to some content artifacts. And then you can use the IG publisher to create that website for you. So this conformance resources that I discussed are actually also used to define the FHIR core specification. So all core data types and core resources are defined by structure definitions. And of course, the operations and cert parameters and terminology are also all defined by those conformance resources. And yeah, we actually also did that to test our own our own structures, and yeah, it worked out pretty well. Another important thing that you need to do when defining a conformance resource is assign a unique identifier to that resource, which we call the canonical URL. This is important because it is an author-assigned URL that is shared by all instances independent of the system where they are available. So for example, if you compare it to the technical resource ID, that is specific for each different system that implements that conformance resource. And it's some ID that is assigned by the server. So if you want to search for this conformance resource, of course, you won't know the technical ID, so it would be hard to find it. And then you can use that canonical URL to retrieve that conformance resource in that particular system. So here on the slide are two examples of what that canonical URL might look like. The first one is from the official FHIR specification. So we start with the domain, which is hl7.org/FHIR in this case. Then with the resource type, the structure definition, and finally the name of the resource. So actually you can define this canonical URL by yourself, but you need to have access to that domain that you are using. And it is also good practice to add the resource type in there because it makes it easier to find it back on your server. And the second one is an example of some imaginary domain called FHIR.alp, where they made a profile based on the patient resource and called it alp core patient. So let's dive a bit more into profiles and extensions. So a profile defines constraints on either a FHIR core data type, a FHIR core resource, or it could also be based on another profile. But you have to be aware that sometimes this term is loosely used to refer the implementation guide or a conformance package. So it depends on the context of the use of the term profile, what the actual meaning is. But when we talk about profiling, we usually mean the first definition. So as I mentioned, you can also base profiles on other profiles. And this is when you get so-called layered profiles or derived profiles. So we see at the top of this pyramid that you have just a couple of core profiles. And then at the national level, we build national profiles based on these core profiles. And then maybe at a regional level, you can build specific profiles for that region based on the national profiles. And at the end, we have very specific profiles at the organization level or even project or use case specific level. And you can see that the more specific it gets, then the number of profiles is growing. But if you take a look at the other side to the resources conforming to those profiles, then of course, there are very few resources actually conforming to the very specific profiles, while all resources in the end should conform to the core profiles. So this is also an important notion that you always should conform to the core profile. So when you are building specific profiles, you cannot do anything that is against the core profile. So for example, if an element is mandatory in the core resource, you cannot say in my specification it is optional. It can only be still mandatory. So we already talked a bit about the structure definition. That is the kind of structure that you are creating when creating a profile. So first you assign it that unique canonical URL. Then you have some metadata like the name, the status, the author, the publisher. And of course, you need to specify to which base profile this profile is based upon. And then that structure definition consists of a list of element definitions. And in these element definitions, you can also make your adaptations. Of course, it has a name. It has some cardinality that you might want to change. It has a particular data type. And then textual definition. You can also add fixed values to these elements. Or you can add even more complex constraints using the FHIR language. For example, to specify a length limit or something like that. You can add terminology bindings. And finally, if you know them, you can add some mappings to other specifications as well. So in this slide, I have a couple of examples of things that you can do when you are profiling a resource type. So first, you could add an extension. For example, the US core patient has an extension called US core race. That's an element that is not by default in the profile or in the resource, but you can add that by using extensions. Then you can also, for example, demand that the identifier that you uses a national patient identifier. And you could do so by setting, for example, a fixed value in the system element of the identifier. And then, as I mentioned, you can also change the cardinality. Of course, as I said, you cannot change it from mandatory to optional, but you can restrict it. So if in the core specification, for example, it is cardinality 0 to star, then you can, for example, change it to 1, 1, meaning that it's no longer optional, but for your specification, it's mandatory. And you're not allowing multiple, but you're allowing only one value for that element. Next one is, for example, when you have a choice data type, there are multiple data types allowed for that particular element. And then you can restrict that in your profile to maybe one of those data types. So in this example, we will only allow a Boolean data type, while in the profile that it is based upon, both Boolean and datetime were allowed. And then you can also point to specific profiles that you created. For example, if you made a profile on the address data type and you want to point to your own custom address data type, you can replace the address data type by your own custom data type. And finally, you can also cross out elements, but you have to be aware that you have to author this with care, because it limits the data that you accept as valid. So while you could also freely ignore this element if it's sent in a resource instance. And something that you could do instead of crossing out these elements, so instead of setting the maximum cardinality to 0, you could also use the should support flag to indicate which of the elements should be supported in your system. So this is an example of a US core profile where they used that should support flag. And if you use that should support flag, you should indicate in your implementation guide what you meant by, because the should support flag indicates that you have some meaningful support, and in your implementation guide, you need to specify what you mean by that. Also, you see in this example that they made the identifier mandatory and the name, they made it mandatory because it was optional in the original resource. And they added some extensions for race, ethnicity, and birth sex. So as I already said, sometimes you would want to add more complex constraints than just changing cardinality or adding fixed values or whatsoever. And then you could use the FHIR graph traversal language. And there is a session on that on Thursday. And it allows you, for example, to do something like this example on the slide. So it says here that if the bundle type is document, then it should have a timestamp element that has a value. And you couldn't just do this by changing the cardinality, because then it would apply to all resource instances. And now you say only the ones that have type documents have this restriction. So when you are creating a resource instance, you also want to be able to say to which profile this resource instance is conforming to. And you could do that by adding the profile in a metadata of that resource. And when you are doing so, and a server has this resource as incoming data to that server, then of course they need to check if this claim that you did, if that is true or not. So they need to try to resolve that profile. And they can do so by looking at the domain if the profile is available there. And if they have been able to resolve that profile, they get back a structure definition, and they can use that to validate the resource instance against that structure definition. And of course, sometimes it's not available on a particular server, but you can also choose to publish it on some kind of repository. Just a little bit more about extensions. I already mentioned them, but the reason that we have extensions is because that Yeah, FHIR is based on the 80-20% rule. So elements that are used in 80% of the cases will be included in the FHIR core resource. But those elements that are more specific to particular use cases and, for example, are only used in 20% of the cases will be excluded from the core resource. But you can add an extension to still include them. And also the core specification has a list of standard extensions that are already available that you could use in your profile. So for example, the core specification has a standard extension available for patient race and ethnicity. And this is something that is mandatory to register in the US, but it's actually illegal to register it in the EU. Sorry about that. So you cannot define it in the core patient resource definition because it's not in that 80% of the cases where you would use this. And also extensions are defined by using a structure definition resource. And of course, again, you need to add a unique identifier. And then you need to define the context of the extension. So that means in which context can you use this extension, which could be either in a particular resource or a particular data type or even another extension. And then it could be at the root of that resource, but it could also be on a particular element within that resource. So then you need to specify the entire path to that element to define in which context this extension is valid. And you can have multiple contexts in an extension. And of course, the extension only needs to be defined once, and then it can be reused in many profiles. So now I've talked a bit about conformance resources and actual profiling. And next thing that you would like to do, that now that you have your set of related FHIR conformance resources, is publish them together in a consistent package that implementers can use to implement those resources. And of course, it needs to be versioned as well, so implementers can trust that this package doesn't change, and they can decide for themselves when they will move on to another version. When you start profiling, you might want to use our profile editing tool, Forge. You can also, of course, use some different tools, but Forge has a package manager, and it allows you to browse and download FHIR packages that are published on Simplifier. So from within Forge, you can add and remove project dependencies. And then you can use that, for example, to select extensions from that package or derive a profile from that package. So, for example, I'm now working on a Dutch birth care project, and I'm using Dutch national profiles. So I have that Dutch national package as a dependency, and then I can select from that package the Dutch NL core patient and create my own version for that. So when you are going to publish your package, your work, there's some official registries. First, we have the HL7 FHIR profile registry. And also when you publish your work on Simplifier, you can indicate if you want that to be available on the official HL7 registry as well, and then it will be made available there. Also, we have HL7 FHIR implementation guides registry, where you can find the official HL7 implementation guides that are generated by the IG publisher. So simplifier is public FHIR registry, and is the driving force behind that official HL7 FHIR registry. And you can use it to search different conformance resources that others created. It contains all the official HL7 profiles and all the HL7 affiliate profiles, but also some public profiles or even private company profiles, because when you create a project in Simplifier, of course, we hope everyone is creating public projects, but we also understand that for some companies, it needs to be private. So you can mark your project as private as well. Yeah, so a couple of functionalities that are offered by Simplifier. So you can validate your examples against profiles. So you don't need to push them to a FHIR server, but you can just, when you have published them on Simplifier, you can also validate them directly in Simplifier or use FHIR terminal to do that. Also, you can see the incoming and outgoing references of your profiles. So you can see if someone else is, for example, using that in their project. As I already mentioned, it's the official backend for the official FHIR registry. And you can also use Simplifier to download FHIR NPM packages. But because, of course, there's also other tools available to create your packages. And finally, we have an implementation guide editor as well, for which Arden will talk a little bit more later this week. But there's also a couple of tools to create implementation guides. And we have recently added FHIR query language with which you can make it more dynamic. So here's a slide on a couple of tools that might come in handy if you are profiling. I have to say this list is not complete. So if you have some tool and you would like to be on this slide, please let us know. We can add you to this slide, of course. So yeah. So what's next? There's a couple of interesting modeling sessions this week. Tomorrow there is one on Forge, which is actually the Let's Build that is related to this tutorial. So you can explore Forge, experience profiling, and create your own data model with Forge. And there's also a nice session about FHIR shorthand, which you can also use to create your profiles and implementation guides. Then Wednesdays, there's a couple of sessions about publishing a FHIR specification, either with Simplifier or the IG publisher. What else do we have? We have another session on FHIR shorthand and FQL. And then Thursday, we have a session on IG publishing and quality control in the cloud. And a session on FHIR and a session on mapping with FHIR. So if you have any questions left after this presentation, of course, we will have the Q&A in a second. But also during DevDays, you can always reach me through either through the Woofa app, chat.phir.org, or send me an email. And for the in-person attendees, of course, you can also go to the FHIR booth to visit us over there and see what FHIR has to offer. So thank you for your attention. I think there's time left for Q&A.
Indeed, thank you, Lilian. There's still 10 minutes left for a Q&A session. So I will look at the audience here first for questions, and later I will check the virtual questions, which I see we have one at least not answered. I'm coming to you. Oh, it's going to be hard.
Yeah. Thank you for the talk. You talked about profiles and how they're defined, but after using the tools that you suggested, what ultimately profiling produces? What is the finality? Are the resources that you talked about, like implementation guide resource and profile resource, are they the product of profiling? What are we producing when we create, when we profile?
So you can see it that way. That's the products of profiling, and then you have created a conformance package, so to say, so that implementers that are going to implement your system know how they should use these resources in their implementation. Does that answer your question?
Wait 1 second, otherwise the virtual people cannot understand what's going on, so I'm coming to you.
Hi, this is Diego from HS7. That's correct, but also this is the first time in history that our guides, implementation guides, can be read as a human, but can also be processed as a computer. So the end product is a package, and you can use the package to validate your instances. So you can find out in your computer or in a server, in any FHIR server, if your XML or JSON is really conformant to this guide or not. Not by reading the guide and thinking that it is correct, but knowing because it's processed.
Yes, that's a great addition. Thank you, Diego.
I see another question over here. It's a big room, so need to jog a little bit.
So the first tool, if I see it correctly, is tailored on Windows system, right? Do you have any effort to make it available on Macs, Linux, other operating system? And my second question would be, so once you produce the implementation guide, you need to upload them to the server. I saw there's a couple of things there, like you have a FHIR terminal or an NPM. Is there a requirement or some kind of guidance on any FHIR server that they need to be compliant with NPM on the FHIR terminal to upload it? What is the guidance over here?
Do you know that, Arden? What
So there were two questions, right? The first one was if Forge will become Forge is currently Windows-based, and it's not on the roadmap to make it Mac or available on the Mac OS. But you can use Wine or a virtual machine to run Forge. Maybe a bit not desired, but that's the current setup. So no planning soon. And the second question, I need to ask if you can rephrase it again.
So once you package the implementation guide, you need to distribute it to a server. You need to upload it to a server to implement it. When I look at FHIR, for an example, there are two options. One through the FHIR terminal, and the other one is NPM. Is NPM and FHIR adapted by all, for an example, servers that are FHIR certified? Or what is the guidance or the control over here to make sure that if I create a FHIR implementation guide, I can upload it to a server with a specific mechanism?
Should I take it or?
Yeah, sure.
So I think those things are two different things. You've got FHIR terminal, which is a command line tool helping you out with all kinds of different things. And then you've got the NPN. That's like a standard on its own, which is being chosen by the FHIR community to actually use as a mechanism to package FHIR resources and to provide them in a stable manner. And if you create an implementation guide now, you would also create like a package of it and you have that available. And then FHIR terminal could be a way to actually push all the package into a FHIR server, but there can be other ways as well. You can upload them to a user interface on a FHIR server. That really depends also on the FHIR server. Does this answer your question a bit? Okay. Yeah. Okay. I see another question over here.
Hi, so I have two questions for you. The first is, you mentioned earlier that you should always be conforming to core profiles. So what's the difference ultimately between a core profile and a resource? Like, is a core profile just a like HL7 stamped like way that you should use this resource, and that's it? And then national profiles, everything derives from that, but it is more specific than a resource. Is that ultimately the distinction?
Yeah, so a core resource is actually also a structured definition. And if I use the term core profile, I also mean that core resource. Yeah. Got it. Okay. Yeah.
Sorry, so are you saying the core profiles are resources?
Yeah, so the patient resource or the observation resource, they are core.
They are core profiles.
Yeah.
Got it. So, okay, got it. The other question that I have for you is, you mentioned at what point that when profiling, say like a patient, you could change the address to be another profiled resource type, like my address resource. Are profiled resource types themselves just considered new resources that extend another resource? Is that like, is a profile
so they
simply
are
a
also
resource?
Structured definitions, and structured definition is a kind of resource as well.
Got it. Okay. All right. Thank you.
Yep.
Thank you. We still have 4 minutes, so yeah, I see another question. Here you are.
Hey there. So I am implementing a FHIR server. I have an extension on the concept map resource. And so far I've uploaded some content to my server just using the extension without registering it or profiling. But I'm just wondering about best practices. And so what is the list of best practices for doing this? Should I define it using structured definition, register it, profile it, use that in an implementation guide, and then upload the content? Or is there anything I'm missing? Or is that mostly what I need to do?
Yeah, that sounds about right. Yes. And then of course you can implement in your FHIR server, you can implement that package. For extensions, did you also want to define a search parameter on that or not?
Did I have to define what? Sorry?
A search parameter based on that extension, or that's not?
Oh, I didn't add that to my list, but that's good.
Yes.
I'll remember that.
If you would like to do that, then there's some FHIR servers that offer dynamic support for search parameters. So then you just define your custom search parameter based on your extension, feed that to the FHIR server, and then they will know how to address that one.
Thank you.
Yeah.
Okay, yeah, running to the other side of the room. Give me a sec. And here you go.
You mentioned that if you're writing an implementation guide and you use the must support tag, you should define what the tag means in your guide. Could you give an example of what that looks like? So I can give let's say I have an element and I say it must be supported. That's different from having a minimal cardinality of 1, right?
Yeah.
So what does the must support tag mean? What could it mean?
Yeah, so for example, if you have a use case now, for example, if we have this data delivery to a quality registry, and I want to be able to receive a couple of elements in that resource, and the other ones, I'm just ignoring them. So I can put a support flag on the elements that I need and specify that if they are, if there's data in them, then the receiving server needs to be able to store that elements or do something with those elements. And what that exact support is, that is something that you need to specify in your implementation guide.
Okay, and could that also include certain operations that you have to support, or is that unrelated? So if you have a must support tag, could that mean that you have to support a search on that element, for example?
No, that's something that you could define, okay, I guess, but.
Okay, thank you.
I think Diego wants to react on this as well.
A short comment on that. Must support is like a gentleman or gentlewoman pact. It means that if you have the information, you are supposed to include it. And if you receive it, you cannot give an error, and you need to process that in some way. This way is not automatically perceived by computers, because it may mean that your system will show the information somewhere. So if you received race or ethnicity and it's must support, you should show ethnicity and race. And we cannot know if you do that. So that's why it's a pact. But the most important thing is, if you have it, you have to include it. Or if you have it because, like, think on immunization. If the immunization is not done, then you need to specify the reason. It's must support. It's not mandatory, because you will need to specify the reason for every instance. So these are kind of examples.
Okay, I see we're about time. I just want to have one little addition to this with the must support flag, because if you add a must support flag in downstream profiles, you cannot remove it. So you need to take care with it. And one quick question from the virtual audience before we enter, because I think it's a very quick question, is, may I create a profile based on another profile and so on?
Yes.
Yes, exactly. So I think this was the final question. Thank you very much, all, and hope to see you this whole week. And if you have any questions, I think we both are available to answer them.
Yeah, we will still answer them in the Whova app after this session. And you will get a notification through Whova that it's answered. So thank you for your attention, and please enjoy the rest of the week.
Sure.